Geoclaw models a shallow geophysical flow. And technically what that means, for storm surge at least, that means the ocean. My work kind of focused on this layered, so a lot of geophysical flows are layered, so they have kind of layers that sit on top of each other. And it plays into the dynamics of the flow. And our thought was, okay, well, storm surge, primarily the wind is blowing on the top of the surface of the ocean, the rest of the ocean isn't being moved at the same time, so let's study that. So this is a simulation of what a representation of Hurricane Sandy would be, and showing the surface height of the water due to the surge. So the redder the color, the more, the higher it is in the water itself. And so you can see water kind of pushing up into the New York City area. The areas that are white in places that there's usually land, that's where it's actually flooded. This is the speed of the water. Right? It pushes in and then goes up the Hudson and then through the East River and then also comes back out. This is a theoretical one where what happens if Hurricane Sandy is about 20% stronger and that the winds are 20% stronger. You just raise up the ocean to begin with by a half meter. So this is one of the greatest things about a tool like Geoclaw is that we can do hypothetical situations where it's like, okay, maybe Hurricane Sandy came the exact same way and we just tweak it. The major kind of components of what a storm does to the ocean and therefore storm surge, there's the wind, which is actually the biggest one. And then there's the pressure. So that pressure, we need to define it. It has to interact with the ocean. And the same thing has to happen for asteroids. It's as they explode in the atmosphere, what's causing it to interact with the water to a large degree is that a pressure wave.
In Russia, was hit by an asteroid that exploded like 20 kilometers in the air above the city. Nobody saw it coming. So they needed somebody to work on what would happen if an asteroid exploded over the ocean. That's how I started working on asteroid-generated tsunamis. This hypothetical asteroid impact calculation that we did, and here is the crater it would have made. Here are the initial conditions. So we placed that 150 kilometers off the coast of Washington. So we have a good idea of the shape of the ocean there, because that's very important in determining how big the waves will be. Here's the entire region. Here are the different meshes outlined in different colors. So it's coming in from offshore into Grays Harbor. We can see that the waves completely overtop the communities of Ocean Shores and Westport. Geoclaw simulations of the tsunami arising from a magnitude 9 Cascadia earthquake show similar effects and are already being used to help these communities prepare. I really like it when my stuff is useful on a real project that can solve problems. That's a big motivator for me. That's one of the big reasons open source software is so good.
There's always going to be cross-pollination of ideas or even just straight-up capabilities. So it's a pretty collaborative type of code, and this is one of the superpowers of open source.